Hello, this is my lab5 for ECE6122. In this project, I'm going to calculate a matrix using CUDA in C++. I have two matrices for calculation, using one to store the current values and using another to store the new values, updated in the current iterator. The key point for this project is how to use CUDA to accelerate the computation. I mean, in CUDA, you can exploit the multi-threading advantages to accelerate your computation. First, I need to confirm how many threads in a block can have in the machine, which is the pace cluster. I can use the function provided by the CUDA to get the maximum size, which is 1024, which means the maximum block size should be 32 times 32. Based on this restriction, then I can compute the number of blocks. So this is the basic idea of how I design these projects. And in order to reduce the time of memory copy, here I don't assign the new matrix to the current matrix each iteration. Instead, I use the iterator number to choose which function, which parameters I pass to the function. That means, like in the first iteration, I pass AD as the current matrix and use BD as the updated matrix. For the next iteration, I use BD as the current matrix and use AD as the new matrix to store the updated value. Such design can reduce the memory copy while calculating this matrix. Now let's see how to run the program on pace. Here I already start a job on the GPU cluster, and I have compiled the source file into an executable file. First, I would like to check about the parameters. If I don't pass any parameters, the program will print an error. And if I pass a negative number, like -10, also print an error. And now we test a base case, which is provided in the lab5 meta thread in Piazza. As you can see, the runtime is 0.28 milliseconds, which is very fast. And now we can see the result. As you can see, this result is identical to the CSV provided by the teacher assistants. And you can easily find this is right because it is symmetric. This value is equal to this value. Yeah, it is symmetric. So that's the basic point of this project. And thank you.